Welcome and hello everyone! I am Radia. Today we will be looking at how solid waste management and treatment can be more sustainable. The flow of the content will be on snippets of Semical landfill, the technology of treatment, the importance of treatment, and lastly the sustainability. Let's look on Semical landfill. It is the first man-made offshore landfill created to hold the trash of Singapore's 5.9 million people. Can you believe it? Many people may have imagined the landfill has a horrid smell. That is not the case. Pulau Semakau is not a landfill full of trash. It is a rich green sanctuary and even stench-free. Sadly, 15 years from now, the landfill will be filled with trash and thus, the lifespan of this landfill is shortening. Let's look at how waste is managed and treated in Singapore. Solid wastes are separated and transported to the designated facility. Municipal waste is sent to the waste-to-energy plant to burn the waste to further reduce the size of the waste. Recyclable waste is transported to a materials recovery facility to be further recycled. As I mentioned in the previous slide, municipal waste is burned in the incinerator and recovered energy to generate electricity. Incinerated bottom ash and fly ash are transported to Pulau Semakau for landfill disposal. How can we make solid waste treatment of incineration more sustainable? As we know, incineration leaves a reduced quantity of waste called ash. There is bottom ash and fly ash. Ashes have their own composition from different types of solid waste. There are municipal waste, industrial waste, and agricultural waste. The focus is municipal waste incineration ash, as we can further repurpose it into useful contributors. These compositions present in the ash can be either extracted or, further treatment process with the use of technology will help to the treatment process more efficient and sustainable. Moving on! Let's look at the technology in the treatment of ashes. First, we have an ash melting furnace, plasma type. It is designed to meet different types of material waste of ashes such as waste incineration residue, medical waste, low-level radiation contaminated waste, and many more. The ash is fed into the ash inlet, melts using ultra-high temperature, and keeps the furnace under negative pressure, which enables to form the ash into recyclable slag and metal production. It is operated with low electrical power to detoxify the ash without causing pollution. Secondly, ash melting furnace, electrical resistance type. It is designed to treat both incinerated bottom ash and fly ash. The ash is fed into the inlet at the top and passes through to be melted by the extremely high heat temperature. It is operated under stable conditions to melt the ashes and produces molten slag and molten metal. This process also reduces the generation of hazardous gas. The quality slag and metal are said to be of excellent quality and can be used for cement concrete. Thirdly, the collected dust/ash dioxin decomposition system. This system is created to treat the decomposition of dioxin and hazardous contents contained in fly ash. The fly ash is fed into the reactor and separates the dioxins and hazardous organic compounds by mixing and fluidizing. Then, further heating and decomposing by high-performance oxidation catalyst, as the treated fly ash does not consist of organic chloride compounds. Fourth is the fuel-type surface melting furnace. It is shaped, inclined, and operated at high temperature, using flame from the burner and radiation heat from the surface walls to melt ash. The ash is fed into the ash feeder located nearest to the melting surface. The ash is then melted and flows down and meets the water granulation system, which then slag is produced. This technology is created beautifully by making use of the ash and waste plastic to replace kerosene, heavy oil, or city gas as fuel. Lastly is the improving the quality of slag equipment. As ashes of bottom ash and fly ash have been turned into slag, we can improve the slag quality with this process. Slags are fed into the hopper, then it will eliminate the iron present in the slag. The non-processed slag is in large lumps and shiny smooth surface. After the removal of iron, slag will be crushed and separated into its sizes. This is a crushing process slag where the size of large lumps is reduced. But this process slag is not yet suitable to utilize. After sorting into sizes, the slag will go through hot water treatment where it is treated with high pH water and high temperature to improve the quality of the slag. It has a similar character to river sand. With this technology, slag stability is boosted and can be utilized for products. Why is it important to treat the ashes? Repurpose is the goal of sustainability. As I mentioned before, ashes have many chemical compositions that made the production of slag to be used in cement products to be unstable and may cause accidents. Efficient consumption of waste helps to repurpose long-term techniques to keep and conserve natural resources. Furthermore, these treatments proposed previously helps to prolong the prevention of environmental pollution. Since electric furnaces are expensive, cost saving and efficiency will be in interest of Singapore to invest long-term. Utilizing plastic waste by reducing the amount of ash waste at the same time increases the amount of waste recycled. Finally, the Semical landfill will be saved from waste disposal and prolong the lifespan of the Semical landfill. Thank you for watching! Let's make sustainability possible!